Okay, 5.5, select a mathematical model. So one of the ways that we can decide whether we're dealing with a linear, quadratic, or exponential function is through first differences, second differences, and ratios. Okay, so I give you one of each example here. Okay, so we're going to say example 1, determine whether the following are linear, quadratic, or exponential by calculating first differences, second differences, or ratios. Okay. Basically, what you want to do is you want to continuously calculate these in order until you find out which one it is. Okay, so here's the table of values. First differences, we're not going to have these specific boxes filled in. So we're going to go up the y-axis. We're going to go 160 minus 80. We're going to get 80 minus 40. Okay, so we get 80. We get 40 for that one, and we're going to keep going 20 and 10. Okay, these are not constant, so it's not linear. Let's keep going. I'll change the color. Okay, now second differences, we go up the first differences column. 80 minus 40, I get 40. Okay, 40 minus 20, 20 minus 10. Okay, these are not constant, so it's not quadratic. Now, let's go up the ratio column. So ratios, remember, we go back to the y values, and we go 160 divided by 80. I get 2. 80 divided by 40. I get 2. 40 divided by 20. 20 divided by 10. Okay, so this one is exponential. Okay, next one, negative 3 minus 0, I get negative 3. 0 minus 3, I get negative 3. 3 minus 6, negative 3. 6 minus 9, negative 3. Remember, first differences are going to be 1 less. Second differences are going to be 2 less. And ratios are going to be 1 less. Okay, however, these already are constant, therefore it's linear. You do not have to complete second differences or ratios. Do not complete. Only complete them in order, and as soon as you find it, then stop. Okay, and the last one, we're going to go up the y column again. 16 minus 9, I get 7. 9 minus 4, I get 5. 4 minus 1, I get 3. 1 minus 0, I get 1. And remember that first the first box, and then in the first differences are not filled in, and in the second differences 2 boxes are not filled in. Now, first differences are not constant, so it's not linear. Let's go to the second differences. 7 minus 5, 5 minus 3, and 3 minus 1. All of those equal 2. Okay, so we can stop here. We don't have to do the ratios, and we can say that this is quadratic. Example 2, state whether the following are linear, quadratic, or exponential. Okay, so just by taking a look at different graphs and the way they curve, or maybe if it's like linear, if it's a line, we can tell if it's linear, quadratic, or exponential. So the first one here, since this looks like a happy face, so it's a U-shaped. Okay, so U-shaped is actually going to be quadratic. Okay, the second one, well, this one's easy. This is just a line. Okay, so this is linear. And exponential either goes up to the right or it goes down to the right, and it always approaches a certain line. Okay, so this is exponential. And we know the difference between exponential and quadratic. Sometimes if the quadratic is like cut off, like if we only see this much of a quadratic, what I just outlined in red here, then it's difficult to tell because it could be it looks maybe exponential, but it could be quadratic. But with exponentials, if you see the entire thing, exponentials flatten out. And that's how we can tell. Okay, example 3, linear versus exponential. Shannon invests $1,000 in 2 different accounts. Okay, so the first account provides interest at 5% simple interest, which is linear, and the second account provides interest at 5% compounded interest, so it's compounded annually, and that's exponential. Okay, so we're going to fill in the chart below by calculating the interest earned and the total amount of money Shannon's going to have each year. Okay, so no matter what, she starts at $1,000. Okay, we're just going to do simple right now. So let's go simple. Okay, so the interest that she earns on simple interest, it's going to be $1,000 times 0.05, and we're just going to put that in for 1 year. Okay, so this is PRT. Okay, that might look familiar in past years, or if you've done it, I know that this year we did the financial mathematics before this portion of the course. So PRT should look familiar. Okay, so the actual interest earned is going to be $50. Okay, so at the end of the first year, Shannon's going to have $1,050. Okay, and then this is linear, so it goes up by the same amount every year. At the end of the second year, 1,100, then 1,150, 1,200, 1,250, and then $1,300. Okay, the amount, I'm just going to change colors. In regards to the exponential, so if we were compounding this annually, what we'd have to do is use P1 plus I to the exponent n. Okay, so we're going to use 1,000, 1.05 to the exponent 1. Okay, 1,000, 1.05 to the exponent 2. 1,000, 1.05 to the exponent 3. 1,000, 1.05 to the exponent 4. And we're going to keep going up until 6. Okay, so in the calculator, okay, so the first year, 1,050. Second year, 1,102.50. Okay, and then 1,157. Decimal 63. 1,215. Decimal 51. 1,276. Decimal 28. And then 1,340. Decimal 10. Okay, so let's go ahead and graph both of these. They're going to be quite similar on the graph. I'm going to graph the exponential one first. Okay, and I'm sorry about the numbers. The numbers on my graphing software, as soon as they get over 1,000, they go from being on the outside to being on the inside. But this, we're going to still treat this as 0. So no matter what, we start at 1,000, and I put that right at the bottom. And then 1,050. Okay, and I use the scale of 50. So truly easy to go up. Okay, this one I actually did the simple interest first. So this one I'm going to put SI, that's fine. Let me do the other one in maybe another color, maybe orange. Okay, so compounded interest, again, same starting number, same second number, and then we're going to go up. It goes up just like 2015, so that's just up a little bit. 2076. So now like we're gapping a little bit, and then 1340. Okay. So if we can see just a little bit of a difference, this is compounded interest. Okay, so after 6 years, which account accumulated more interest and by how much? So at 6 years, compounded interest. And if we take the two amounts, it wants us to say by how much, 1340 decimal 10 minus the 1300 that you would have gotten. So the difference is $40.10. Me personally, I'm going to take the $40.10. Okay, in the long run, which account is more beneficial if your goal is to make more money? Okay, simple interest or compound interest? Well, definitely compound interest. Because this interest and this amount, the amount will continue to grow faster than the simple interest.